Hello everyone. We are going to give an explanation of what it is the expected monetary value. Uh, we are going to do this with an example. First, let's read it. Let's suppose the professor proposes that you participate in a game of chance. You have two options, participate or not to participate. If you decide to play, then the professor flips a fair coin. If the visible side of the coin when it lands is heads, then you win 2000 soles. Otherwise, you lose 1 sol. So they are going to ask to create a payoff table using the criterion of expected monetary value. What do we decide to participate or not to participate? Suppose you decide to play. Now we simulate 30,000 games and calculate the average utility. Then we must explain the relationship between the expected monetary value and the selected alternative from item A and the average utility. Let's do it. So here it is a model in Excel that we are going to fill. First, we have to complete the payoff table. Remember, if we decide to participate and the coin lands in heads, we win 2000 soles. So we put 2000 soles. Otherwise, we lose 1 sol. If we do not play, we have 0 as earnings. Also, the probability, because it is a fair coin, it is 0.5, 0.5. So how do we calculate the expected monetary value? Well, it's the multiplication of the utility times the probability. 2000 soles times 0.5 plus minus 1 times 0.5 for this option. Another faster way is use sum product. With sum product, we click on this, we click the row and the probabilities. It's comma and the probabilities. We fix those probabilities because we want to drag the formula. So we have the EMB for play, the alternative play, and for the alternative do not play. In this case, the highest expected monetary value comes from playing. So the best alternative following the criterion is to play in this game. Okay. Remember that this expected monetary value of that alternative gives us the long-term average profit that we get if we play infinite times, many times this game of chance. So we play many times, and in all those plays we decide to participate in this game, then in average we are going to win 999.5. Okay, that's the intuitive explanation. So we are going to show that in fact this is true. How is that? We are going to simulate this game of chance, this flipping of a coin, many times. In fact, we are going to simulate it 3000 times and calculate the average profit. This average profit must be near this expected monetary value. So let's do it. What's the probability of getting a head in a coin? 0.5 and tail 0.5. We know that the face of the coin is a random variable. So we are going to simulate that random variable. How is that? We are going first to construct a discrete distribution table and use a command in Excel. Instead of head, we are going to use 1. We have to complete this table, and instead of tail, let's put 0. So how do we generate this face of the coin? Well, with the command VLOOKUP. VLOOKUP, we put a random number because we are going to generate it. Then we put the last 3 columns of this table. Then the column 3 because we are going to replace the the number that is searching between in the first column for the number in the third column, so 1 or 0, and then 1 because we're going to do an approximate search. Oops, sorry, I put some is comma, not a dot comma, so let's put comma. So in this case we get tail. What's the profit? Well, depends, right? If we get head, we get 2000 soles because we are supposing we are playing. If we get 0, we get -1. So if a conditional. If this equal 1 or heads, then we get 2000 soles. Otherwise, we lose 1 sol. I'm sorry, always comma. I always forget to put a comma. Okay, then we are going to simulate this toss of a coin many times. So let's put this, and let's simulate it many times. So we select the whole table, put data, what if analysis, data table. In column, input cell, we put an empty cell, okay? B1, for example. And okay. Automatically, your table will be filled with the 3000 simulations. For example, the first simulation, we got head and we win 2000 soles. In the second simulation, we got tail and we lost -1 sol. So let's get the average. Average, or the mean, of these many games that we have played. And look, this number is near the expected monetary value. And just to fill this information, let's put the standard deviation of the profit also. So you can, oops. Yes, so you can see that the average is near the expected monetary value. If I simulate many times these 3000 games, you can see that always lands near. Of course, it's not always it's not the exact number at the expected monetary value, because a Monte Carlo simulation gives you an approximation of the optimal number. The optimal number, if you play many times, infinite times, you get these numbers a profit. But in the Monte Carlo simulation, we get this. So hopefully you like this case. Remember that the learning of this case is that the average profit in long term approximates the expected monetary value. See you.